All right, so the first thing I want to do is show you where to find the test, and then I'll open up the worksheets. I'll work it in reverse. I'll go to 4.2, part 2, and back it up. That way they were doing the last things first. So let me share my screen here. You all should see Canvas. Hello, you all see Canvas?
Yep.
Yes.
All right, so they're called exams, but you're gonna find it right here on the quizzes. I think, well, I'm not sure this percentage that people have taken quizzes in Canvas before. This is where you'll find it right here. Now, you're not gonna actually see what I'm gonna see, but I want to open this up. It just says basically greetings all. The exam will open up at 11 o'clock on Tuesday tomorrow. And it closes at 11 o'clock. Now, people seem to think, well, I can start it at 11 and then, pick it up at 2. No, you got 150 minutes, which is 2.5 hours. All right. And there are 35 questions. But once you begin the exam, you must complete it in one sitting. It's not like you started at 11:30, you go to lunch, come back and pick it up at 2 o'clock. No, that doesn't work. There are 35 questions. And for security measures, once you answer a question, you can't go back to previous questions. So make darn sure, that you've got it right. Most answers, that involve any kind of numerical answers, the answers will be spot on. So if you're not getting an answer, you don't see it there. I mean, maybe a case where you're off by a tenth or a thousandth, but the answer is going to be pretty much spot on. I just had a thought and it just escaped me. When you after the exam, you'll see a score immediately. You won't see what you got wrong. You won't see that until everybody in your class has completed the exam. All right, so there's the situation. Now, if I go into student view, let's see if I can see student view here. All right, this is what you're seeing now, right? It won't open up until tomorrow morning and it closes. So here's how I get it. Here's what I suggest. You've got, if I go to, let me see, I'm in 20. Some people may be in section 22. But my suggestion is I printed these, I got PDFs. Now they're contained in other spots in the course, but I sort of just summarized them all here. So you see the answers to 1-1 and 1-2. I would have these printed out by my side, or at least be able to find it real quick, because the exam is going to mirror what you've done for homework. It's not like I'm going to come up with a whole different question. It's multiple choice and it's pretty darn close. It's not going to be the exact question, but it'll look real similar. If you go to chapter 4, we're not into section 4.3 yet, but you may want to download these, maybe not print them out, but at least download them so they're in a folder. Because if you come across a question, it's an and or an or question, you go, oh yeah, I remember like one like that on my homework. Open it up, see how I did that question, and basically follow the same routine. Does that kind of make sense to you folks?
Yes.
Yeah.
I'll be very true, I'll be very forthright with you. I've got a test generating program. And why are you biting your nails, Ann? And why are you biting your nails?
I'm not.
Yes, you are. I saw you biting your nails.
Because I'm a nervous Nelly.
Oh, stop it. Stop it. Stop it. You gotta have some self-confidence, Ann. Get some self-confidence. Think about a baseball player, and when he's up at bat, he's not saying, I'm going to strike out. I'm going to strike out. Guess what? He'll strike out. All right. Or girls softball. If you watch that on ESPN, they go up to play. These girls think they're going to hit home runs, and a lot of times they do. Now here again, I lost my train of thought. I have that stuff readily available. Oh, I know what I wanted to say. In my test generating program, when I'm picking homework examples, I may pick 1, 3, and 5, the odd ones. Guess what I do for the exam? I pick 2, 4, and 6. So the DNA, I call it, is so similar. All right, let me get started because already it's 7 past. What I'm going to do is I'm going to open up section 4.2, part 2, the last thing that you had for an assignment. And what I'm going to say is, do you have any questions? And then if you do, give me the number and I'll kind of walk you through it. I think, of course, me, having done this for 88,000 years, I think my voiceovers do a decent job. Well, actually a more than decent job of explaining how I came across the answer. But that doesn't mean sometimes, a lot of times when I explain something, you don't get it, and you ask somebody else, they go, oh, I get it now. So that being the case, what's opened up is section 4.2. And how you'll know what it is, well, I don't have the answers here, but this is 4.2, part 2. These are the or questions. Do we have anything from 4.2, part 2? No, but I don't want to waste your time, and to be quite honest, I don't want to waste my time. So if you don't have any questions from 4.2, I'm not going to just kind of sit here. I'm going to move on. That makes sense? Somebody?
It does. On 4.2, part 2, on number 5, how exactly did you
5,
get
okay.
6, 7?
Okay, because, all right, so if the probability of something happening is 1/7, find the probability of the complement. Well, you know that the probability of A plus the probability of not A is equal to 1. So if I know what A is, I'm going to take the probability of A and subtract it from 1. Now, 1 is as a whole number is equivalent to 7/7. 7/7 take away 1/7 is 6/7. Make sense? 1 whole is 7/7. Hello?
Yes, I got it. Yep.
It's like saying, okay, I got $1, I take away a quarter. What have I got? I got 3/4, right?
Like it couldn't be any more simple than that.
No, but don't feel bad, because I'll talk about you later on to my wife, and I'll say, you don't believe the question this girl just asked. But no, seriously, if you don't know something, there's no disgrace in saying, I don't know. People go through life thinking they know stuff. No, you don't know something, I'll explain it. Guess what? Now you know it, right? Nothing
Yes.
worse than, you're striving for 100, right, on the exam, but nothing worse than getting an answer that you should have gotten right wrong. A hard one, you go, yeah, this was difficult, it was one of those at least one problems. I got it wrong. But something this simplistic, don't you kind of kick yourself if you get it wrong? And
Yeah.
all right. So if that was, let's say 2, well, I'll leave it alone. 1 minus 1/7 is 6/7. If it was 1 minus 1/8, it'd be 7/8, right? Because 1 whole is 8/8. Make sense?
Yep. Yep.
Okay. Anybody else? Section 4.2, part 2.
1 second. Can you go a little bit down? Wait, the last. A little bit down. A little bit more.
That's the last one, 15.
Oh, that's the last one? Oh, okay. No, maybe not this one. Okay. Maybe it's the other one, the other.
All right, I want to move on to 4.2, part 1. Okay.
Okay. Yeah.
I just don't want to waste anybody's time. I have to open it up. Give me a sec. 4.2, part 1. These are the and situation. What's the probability that this happens first and something else happens second, and maybe something else happens third, and so forth? What do you got for me?
Can you go to question 5, Professor
Sure.
Gomes?
All right. When we have the and situation, the first thing we know is that we're multiplying probabilities. I tell people this: if you have an and problem and you are adding, you're doing it wrong. And problems relate to multiplication. Now, in many cases, the word and, what's the probability this happens first and something happens second? But a lot of times it's just implied. When you have an or problem, the problem will say, hey, what's the probability of this happening or something else happening? The word or will always be in the problem. Now, if I read this, in the town, 39% of all the voters are Democrats. If 2 voters are randomly selected for a survey, find a probability that they're both Democrats. But the problem is saying, hey, what's the probability the first person is a Democrat and the second person? Because if it was an or problem, the word or would have to be there. So and is applied. Now, what we have to figure out with the and problems, are they dependent or independent? Dependent would mean, hey, the outcome of the second thing was affected by what happened first. For instance, if I'm picking marbles, I'm picking red marbles. Let's say there are 5 of them and there are, let's say, 10 marbles all told. Well, I pick a first one, it's a red one. Well, now when I go back to pick another one, guess what? There's one less red one and there's one less total. Now, a lot of times the things are independent. For instance, rolling a die, the outcome of the first roll has nothing of, does not affect what happens when I roll the die the second time. They're purely independent. Whenever, listen to this now, whenever you have percentages, even though the problem in essence is dependent, because if I pick one Democrat, you would think there'll be less Democrats to choose from, is one less, and the total has decreased by one. But since it's a percentage, all right, since it's a percentage, you always, when you have percentages, you treat the items, the problem as being independent, which means what happened first has no effect on what happened second. So initially, the probability of picking a Democrat is 0.39. All right, 39% is as a decimal 0.39. You treat the second event, that this first thing happening had no effect on the second thing happening. In other words, people want to do this. They want to go, oh, the probability of picking a Democrat first out is 39%. Then the probability of getting another Democrat is only 38%. They want to take one away from the percentage. That doesn't work. The only time that would work is if you had exactly 100 people. Well, you don't know that. So simply stated, whenever you have a percentage, you treat the problem as being independent. Now that works out well for you because you use the same probability over and over again. In this particular case, we're only picking 2 voters, so it's 0.39 times 0.39. Now watch what happens in number 6 here. The manufacturing process has a 70% yield. Oh, percentages. I'm going to treat these guys as being independent. In other words, the probability is not going to change. It's always going to be the same thing. The probability of finding an acceptable item, if it has a 70% yield, first one I pick is 0.70. Probably getting the probability of getting an acceptable one is 0.70. Guess what it is for the second? 0.70, and 0.7 for the third. If I had a fourth one, it'd be 0.70. So simply stated, whenever you have the problem dealing with percentages, it's fantastic because the probabilities stay exactly the same. 0.39, and getting back to your problem, 0.39 times 0.39. First of all, it was implied it was an and problem, because if it was an or, I would have to have the word or there. Even though the word isn't stated, it's implied. What's the probability of getting a Democrat first and another Democrat second? Does that answer your question for you? Why they're both 0.39?
Yep, so I could just look at that and then automatically look at the second one and be like, okay, so that's a percent. So I'm looking at independent. I'm looking at it.
Exactly,
Okay.
exactly. Okay, now in number 7, it's kind of the same idea. Well, it's not percentages, but notice what's happening here. These items are done with replacement. So I took I found a light bulb that was good, but then I put it back into the mix. So I started the whole process all over again. This is why the probability doesn't change, because it is done with replacement. If it wasn't done with replacement, the probability of getting a good light bulb with first time out would be 69 out of a total of 78. Then it'd be 68 out of a total of 77. Then 67 out of a total of 76. You follow me? Because then,
Yeah.
you know, what would happen if it wasn't done with replacement, then you're talking about dependent. There's going to be one less good one and there's one less total. So I got to subtract one from the numerator and one from the denominator. But with percentages, it's pretty straightforward. You're using the same percentage over and over again. In this case, you know, number 8, it was 3 items, and number 5, I'm sorry, number 6, it was 3 items, and in number 5, it was just 2 items. And problems, we're doing multiplication. Given percentages, you treat them as being independent. Here again, number 8's the same thing. You know, probability of finding somebody with health insurance is 79%, all right, 0.79. All right, so if I pick 4 adults, guess what? 0.79 for the first, 0.79 for the second, 0.79. But a fast way of doing that is taking 0.79 and raising it to the 4th power. Are you people pretty adept at taking a number and raising it to a power?
Yes.
Yeah.
Yes.
All right, on the calculator?
Yeah.
Good. What else? Let me see if I can get I'm trying to erase these things here. Hold on a minute. I guess I can't undo. That's weird. Nothing else?
Let's see.
Okay.
Yes, sorry if there's noise in the background.
Right.
Can you do a quick review of 13 and 14 or one or the other?
Yeah, no problem. Do them both. Let me just close this up for a second. And I'll open it because I got those blue marks there. Okay. Let me exit out of this. I wanted to open it up again. And hopefully I don't see the blue marks. Wrong thing. 4-2 part 1. You're saying 13 and 14?
Yes.
Okay. Okay, what the main rule here is to find a probability, it's favorable over total, but since these are and problems, all right, we know first of all, we're multiplying, and these are strictly dependent events. He says, hey, what's the probability of picking two different people from 948, which is very important, that's the total. Find a probability that they're both heavy smokers. Now, the word and is not here, but it's implied. It's saying, hey, what's the probability that I pick a heavy smoker and I pick another heavy smoker? Well, it's favorable over total. Well, heavy smokers, I have it circled there. What's the total of heavy smokers? 81. So first time out, I have an 81 out of 948 chance of getting a heavy smoker. Now, when I pick that heavy smoker, I put her off or him off to the side. Well, guess what? When I go back again, I haven't got 81. I've only got 80 heavy smokers. I don't have 948 people. I've only got 947 people. If I were to do it a third time, I'd have only 79 heavy smokers and a total of 946. These are dependent, meaning the probability of the second thing depended on what happened first. The probability of the third, if I had thing, would depend on what happened first and what happened second. I have less heavy smokers and I got one less total. If I did it a fourth time, it'd be what, 78 out of 945. You follow me? Dependent events. Number 14, same idea. He says, hey, what's the probability if I take two people from 884 total, they're both women? Well, women, how many total women do I have? I've got 506 to choose from. So first time out, it's 506 out of a total of favorable over total 884. Okay, I picked that young lady and she stands off to the side. Well, guess what? When I go to pick another woman, I've only have 505 to choose from out of a total of 883 people. If I did it again, it'd be 504 over 882. Hello? Make sense?
Yes, it makes sense. Thank you.
Okay, where were you confused?
Just when I was reviewing it, I just was a little confused
I
about,
understand. That's why you logged on tonight, right?
exactly.
Okay. Anything else from 4-2 part 1? All right, take you at your word. Take you at your word. Let me open up. Let me open up 4-2. Well, no, let me do this one. Let me do the of all the problems here, these at least one give people the hardest time. This is the if you see at the very top, it says at least one answers to at least one practice. All right, which is actually working with the and problems. Anything from this? This was part of one of the homework assignments towards the end. You know, the at least one, the probability of at least one is 1 minus the probability of none. You know, I went through this and I gave you the PowerPoint. I had 5 kids. I said, hey, what's the probability of at least one kid attending Brockton School? Well, at least one means one or more. Is it 1, 2, 3? And if it's 3, you don't know which 3. Is it Brenda, Steve, and Kathy, or is it Karen, Steve, and Billy? All right, so the way to get around it, because we don't know how to find exactly 1 or exactly 2. We will find out real shortly in chapter 5. The easiest way, the way to do it is find a probability of at least 1 is 1 minus the probability of none. All right. If there's no questions, I'm not gonna confuse the issue. If you've got it, you've got it. Can I move on from this, or do we have anything from this section?
Yeah, I don't really understand this section though.
Well, give me a specific question. I can't reteach it in 45 minutes, or actually I've only got what, 37 minutes. Give me a specific problem that you have an issue with.
Wait, yeah, we can move on. Let me look for the one that I didn't get.
Yeah, okay, we'll get back to you. Who am I
Yeah.
speaking to?
Alexandra?
Okay, we'll get back to you, Alexander, when you find out
Okay.
what you're looking for.
Let me find, yeah.
Yeah, you find it and we'll be around.
Okay.
So 3.2. This is sections 3.1, 3.2, and 3.3. You all see this?
Yep.
Yes.
Okay. Anything at all from 3.1, 3.2, and 3.3? All righty, I'll take your, usually this is where people ask me questions. Whenever you're given a frequency distribution, all right, you got 12 employees who made between 5,000 and 1 and 10 grand. Well, you don't know whether 9 of them who made 7 grand, whether 6 who made 8 grand. Whenever you're given a frequency distribution, you have to find the midpoint. How do you find the midpoint? You take the low number, you add the high number and divide by 2. Now, once you do that, you see here that the range, the class width is 5,000. Once I know the first answer, I keep adding 5,000 to all the remaining ones. You put the midpoints in one list, you put your frequencies in the second list, you go to stat, calculate one variable stat, you tell the calculator, L1, my frequency is in L2, and I'm looking for the standard deviation. The standard deviation is S of X. In this particular case, it comes out to be spot on. There was one of these that had a little bit of error, and I forget which one it was. It was off by 50 cents or so, something. All right, if there's no questions, I'm going to move on. I'm going to move on. I don't want to waste your time, get things to do. I don't know what you're doing on a Monday night. I don't know what I'm doing on a Monday night. That was 3.2. I'm sorry, that was 3.2 and 3.3. This is This is 3.1. Mean, median, and mode. Pretty straightforward stuff because you've had this, and your calculator does it all. Anything from 3.1. Here again, we got that frequency distribution. Yeah, this is the one that was off by 50 cents. This answer was 50 cents, and this answer did. So this happens very infrequently where the answer doesn't match up to your calculator. And pretty much my answers are spot on. I mean, you may be off by a tenth or two, and that'll change as we move on. But right about now, they're pretty much here again. Frequency distribution. It takes time. You know, I think what happens when people get these wrong, they don't want to take the effort. They don't want to find the midpoints. And well, if you don't want to find the midpoints and put those in list 1 and then take the frequencies and put them in list 2, if you don't want to take the time to find the midpoints, you might as well just mark the problem wrong. It has to happen. You've got 35 problems, you got 2.5 hours. To be quite honest, the majority of people will finish in about an hour and a half. But I'm not rushing you, but just be aware here's what I tell people. If you're struggling and it's taking you like 15 minutes to do one problem, just mark something and move on. Take the hit. I would rather get 1 wrong than jeopardize getting 6 more wrong at the end or not being able to finish because time ran out. And I can't give you, it's just not a situation. No one's supplied me with a IEP. So no one in either class qualifies for extra time. If you had an IEP, you should have gotten it to me a long time ago and I could have made arrangements. There's one young lady who's taking off on vacation. She got a hold of me, and she's starting her exam a little bit earlier than the rest of the class, so. All right, so that being the case, then I'm gonna go to 2-1, 2-2, and 2-3. And let me share my screen. And there we are. Find the class boundary, subtract 5/10 from the lower, add 5/10 to the higher. You know, in comparison to doing the ors on the ends, these guys here, here's what I'll say about cumulative frequency. It always starts out with the words less than. So right here, I don't see the words less than, so I know it can't be letter D. Look at the first number here, the number of cars that were less than 30. Less than 30, there were 4 cars. There it is. Once I see that answer, and there's no other answer that has 4 for the first cumulative, I've got it. Move on. There it is. You know, how did they get to 20? They took the 4, they added the 16, got 20. How did they get the 80? They took the 20, the previous total, they added the 60. How did they get 100? They took the 80 and they added the last group. But when I saw this was 4, I know it wasn't D because it didn't have the words less than. And this had 100. That's wrong. This one had, I don't know where you got 0.04. Bingo. You know, don't waste time. Once you have it, move on. Move on to the next. I mean, you got 2.5 hours, but you don't want to waste an inordinate amount of time on something that is fairly straightforward. Anything at all in 2-1, 2-2, and 2-3? Okay. And then there's only one more left. There's only one more left, and that is 1-1 and 1.
Professor Gomes.
Yeah.
That scatter plot, that scatter plot one where you have the X and the Y axis.
Yeah.
Where does the negative, I'm always looking at, where does the -5 actually plot on it?
Hold on, let me go back to it.
Sorry.
Not a problem. I tell you what, let's just take care of this. 1-1, 1-2 before I go back. 1-1 and 1-2. Let me just say this about this. You see, when they ask you, it says, hey, what type of sampling? Random, stratified. I don't know if I mentioned this before. I may have done this in one of the other office hours. When you have problems of this type, the answer will never, never, never be random. There'll be 5 choices. The answer will never be random. Now, if you look at this guy here, this answer was random. You'll never have a problem like that. It's either going to be cluster, convenient, systematic, or stratified. Your answer, when I ask you what type of sampling is being illustrated, all right, random will never be the answer. That's why I put lines through these. It makes sense? Please do not answer random. It's either going to be convenient, stratified, or convenient, stratified, cluster, or systematic. It never will be random. You know why? Because random is included in cluster and random is also included in stratified sampling. So it doesn't make any sense that the answer could be random. Never, never be that way. All right, so I want to, what do I want to do? I want to go back to, where was it? 2-1, 2-2. I had a young lady asking me a question. I think it was a young lady. Two, one. Okay, we go back to that one there. Who had a question for me? Someone wanted me to go back. Hello?
Yeah, Professor Gomes, I just want to see where the -5.
Oh,
on
the
scatter
scatter plot. Yeah, okay.
plot. Yeah.
All right. All right, so it's like plotting back in when you had geometry. How do you plot the point -5, 3? Well, you start at 0. -5 means you go 5 to the left and 3 up. 5 to the left and 3 up. So I went 5 to the left and 3 up. There it is right there.
Thank you.
Okay, -5 and then 3 up. And to be quite honest, I don't think I even waste my time with scatter plots on the exam. There's not gonna be, we did a lot of problems, and 35 is a lot of examples But this is why I'm giving you 2.5 hours. Give me 1 second, please. Here's something else I want you to be aware of. It's not like a little game and I'm looking to trick you. You know, there was an example, I may have mentioned this before. You know, what's the probability it turns dark tonight? The 3 answers were 0, 1/2, and 1. And this person answered 0.5. Well, it's a sure thing it's going to get dark tonight. Probably is 1. And the person says, well, what if we live in Alaska? And I opened the door, you know, I said this in the video. I opened the shades or the curtains. I said, first of all, it's dark out. It's like 9 o'clock. It was a night class. I says, do we live in Alaska? What I'm trying to say is don't look for the craziest thing. You know, I'm not looking to trick you, you know, that weird example that happens once in a million. No, answer the question and move on. It's not like I'm trying to trick you with, you know, trying to trap you into, oh no, we live in, what if the person lives in, you know, Greenland? No, if you live in Brockton or Haverhill or whatever you live in, you know, guess what? It's going to get dark tonight. It's a sure thing. Probability is 1. What I would say is I found over the years that sometimes I assume that people, everybody plays cards. So what I'm suggesting is, you know, I've found out over the years, I had one young lady, she was from Nigeria. And she said, Mr. Gomes, in my country, women aren't allowed to play cards. All right. So that being said, if we have questions that deal with a deck of cards, make sure you're printing out this slide right here, because, you know, sometimes people want to consider an ace a face card. No, face cards, there's 3 in every suit, Jack, Queen, and King. Why? Because they have faces on them. So total, there are 12 face cards in a deck. All right. So if you don't familiar with cards, print this out. I used to have asked people to go out and buy a deck of cards until I finally printed this thing out. And the second thing is when you're rolling 2 dice, someone says, hey, what's the probability of rolling, let's say, a 5? Well, there's 1 way, there's 2 ways, there's 3 ways, there's 4 ways. There's a total of 36 different outcomes. The probability of rolling a 5 is favorable. How many ways can I roll a 5? A 1 and a 4, a 2 and a 3, a 3 and a 2, a 4 and a 1. Favorable would be 4 out of a total of 36. 4 over 36. Obviously, I reduced that down to lowest terms. The point being this: if you're not familiar with cards, all right, or if you're not familiar with rolling die or dice, you know, I assume sometimes everybody played board games, you know, with their family when they were young, Monopoly and stuff. But it's not the case. We have a lot of foreign-born students. So if you're not sure about rolling 2 die, there's the sheet right there. And hold on a second, get rid of this annotate. And if you're not familiar with cards, make sure that you have this here. Face cards, there's 3 in every suit. Clubs, spades, hearts, and diamonds. Make sense? Anyone here go to casinos? Anybody a gambler? Brandon, do you gamble?
No, I don't. Do you have to be 21 to do that? Because I'm only 20.
I don't even know. I haven't been. Last time I was in the casino was in Las Vegas. That was years ago, and I was 21.
Yeah.
So
Yeah, but no, I mean, I couldn't play poker or anything, but I, played half-heartedly. But I would say no. But I'm familiar with cards overall.
Naomi, you're pretty quiet tonight. Naomi,
Yeah, it's just my daughter is in the background making
how old is
noise.
your
So
daughter? How old is your daughter?
she's 5.
Is she going to help you tomorrow with the exam?
Oh no, I'm leaving the house when I need to do it.
Anything else I can calm your anxiety? I don't want you to be all nervous like Ann. Ann's hair is dark right now. For the next test, it'll be completely white.
No, I buy boxes for that.
And you got a sense of humor, and so do I. So I'm teasing you. You take it in good stride. I act crazy sometimes. Patricia, we see your doorway and we see something on the top. It's got a face on it. I'm not sure what that's all about. Patricia, she won't talk to us. Miss AC, ¿qué
Yes.
pasa? ¿Cómo estás? ¿Está bon?
Muy bien, gracias. ¿Y
Well,
usted?
yeah, comment ça va? Ça va bien?
Ça va bien, merci.
All right.
Could you please go back to 4 part 2, number 18?
4, 2,
Yes.
part 2.
Yes, 4 part 2, number 18 and 17.
Okay, give me a sec. I will find it for you. Number 18. In a blood testing procedure, blood samples from 6 people are combined into one mixture. And why they do that is to save money. You know, so let's say your company is doing drug testing. Well, they're going under the assumption that you're not using drugs. So just rather than testing one person at a time and then spending money, they group 6 people together. Now, the only way it'll test negative if one or more people are using drugs, all right? Then the thing comes back, then they gotta test each person individually. All right, so the test will test negative if all individuals are negative. Now, what's the probability the mixture will test positive? Well, it'll test positive if one or more people are positive. But here's the great thing. Theoretically, you know, you've got 6 people and then you take one out of it, you got 5 people left. But notice they give you the probability as a percentage. The probability of testing positive is 0.11. Well, if the probability of testing positive is 0.11, the probability of testing negative is 1 minus 0.11. It's like that problem we did first. The probability of something happening is 1/7. I take 1, I subtract 1/7. The probability of whatever was 6/7. All right, so if the probability of being positive is 0.11, the probability of being negative is 0.89. The only way that this thing will test positive if one or more people test negative. So probably of a positive is 0.1, the probability of a negative is 0.89. Now I like this because theoretically these guys are dependent, but since I'm giving my probability as a percentage, I can use that 0.89 for all 6 people. 0.89 times 0.89 times 0.89, because it's an AND problem. The first person tests negative, and the second person tests negative, and the third person tests negative, and so forth. I like this because I can use the same probability over and over. I don't have to be subtracting one from the numerator and one. But this only happens, it only happens when you're given, in this case here, it wasn't given as a percentage, it was given as a decimal. But guess what? A decimal is theoretically a percentage. Make sense?
Yes.
Makes a real easy problem out of it. You follow me? As
Yeah.
opposed to something like, let me see if I can find one where, all right, here's a perfect case here. Here, you're not given a percentage or a decimal. He tells us we got 16 people that are 16 calculators that were defective and 30 that were not defective. You know what he hasn't told me? He hasn't told me the total, because the probability of something happening is favorable over total. Oh, wait a minute. If 16 have no defects and 16 have defects, guess what? I got a total of 46. So to calculate the probability, it's 1 minus the probability that none were defective. Well, first time out, there's 30 that have no defects out of a total of 46. Oh, I pull that one off to the side. Guess what? There's only 29 that have that are no defects out of a total of 45, and then 28 out of 40. Well, guess what? I kind of made a mistake here, didn't I? Check this out. You see my mistake here? That's the first time
Oh,
somebody.
yeah, 45, the
Yeah, it
45,
should have been what? 40.
44,
And this guy should have been what?
43.
Thank you. You're the first person that's picked up on that. My apologies. You saw that, didn't you? You follow me, folks? 30 out of 46. Take 1 from 30 is 29. Take 1 from 46 is 45. The 28 is right. The 27 is right. But this should have been what? 44, and that should have been 43. 43. My bad. I got to fix that. You're the first person who caught that. You're the first person who caught that. So apparently when I did it in my calculator, I did it correctly. I just wrote it down incorrectly. You follow me? Because I did get the what? I did get the correct?
Answer.
Yeah, but when I did it on my calculator, I had my brains plugged in. When I wrote this down, I had my brain unplugged. You follow me? I've got to go now and do what? Make sure I fix it before the next class. Thank you for, who was that who just said that to me? Whose question?
Alexandra?
Alexander, you caught. We're all going to give you 5 points, Alexander, not me, but the
Oh,
rest of
thank
the
you.
class is going to give you 5 points. Class, do you agree? Brandon,
Yes.
you giving it 5 points?
Definitely. Yeah.
Brandon, you giving it 5 points?
Yeah, I would give her 10 if I could.
Good answer, Brandon. Good answer. I
Thank
gotta
you.
fix that. Thank you for pointing that out. Hey, as good as I am, I'm still human. And humans, by our very nature, are prone to making what?
Mistakes.
Mistakes. And even Professor Gomes. Yes, I'm human like everybody else. Alexander, thank you for pointing that out.
You're welcome.
I don't take exception to that. I want to be correct. That's why I depend on you. So and this is applicable to any class. Don't be afraid to question your professor. If that professor is truly a man or a woman who is a professional, they will thank you for catching the mistake. Any professor goes, oh, well, I would not choose that professor again for any class. Granted, you'll make more mistakes than I do, but I'm human. And occasionally, in a 15-week or a 5-week course with a lot of material, it happens. Thank you for pointing that out.
Okay.
All righty. So tomorrow, anybody plan on logging in at 11? What's your game plan? And what time do you plan on logging in?
Well, seeing as where I work until 3 o'clock in the afternoon.
Yeah. Make it sound like it's my fault and you work at 3 o'clock.
No, I'm not. I
Come on
plan
now,
on
man.
coming home,
Raise your hand
probably
if you think,
eating
yeah, it was-
something.
Raise your
And
hand
then-
if Ann thought it was my problem. She works at 3 o'clock. Patricia's finding that funny. Well, la-di-da, poor baby. Where do you work, Ann?
I'm a nurse.
My mom right now is in St. Anne's Hospital in Fall River. And I tell you, to be a nurse, you got to be a special individual. The type of care that they give and the way they are with the patients, I mean, it's a calling. It's not a job, it's a calling. And I'm so appreciative that they're taking good care of my mother, Nurses don't get nearly the respect.
A lot
that
of
they
people do
deserve.
say that. I think it's just who you are. When you're a nurse, it's just who you are.
But it's not for everybody, It's a special calling. I had this young lady today. She was just going out of her way to help my mom out. And they walk in and they're just so kind. It's just a calling. What hospital? What do you work in a doctor's office or what?
No, I actually work in a group home for developmentally disabled individuals.
Oh my gosh, that's even more. Yeah. Wow.
I don't know. I've
Congrats.
been at it for 21 years. So
21 years and you're only 29. I don't see you. You started when you were 8.
yeah, definitely 29. So I was in my diapers when I started. I learned how to walk there.
Patricia, she's a hot ticket, huh? Isn't she?
Yes, she is.
She gives as good as she gets, huh? A lot of times when I start teasing people, they get into a shell. Not Ann. Okay, so you've got until 11 the next month. So you plan coming home, eating supper and getting all your stuff
Probably
together.
perusing through my notes a little bit and then,
Sure.
a couple deep breaths and then I'm in it.
Yeah. No drugs though, right?
No. Maybe
No Quaaludes
coffee,
or anything like that or any
some caffeine, an energy drink.
caffeine. Yeah. I gotta go in for an endoscopy. Apparently I'm drinking too much coffee and drinking too much soda. You know what I think it is dealing. My mother-in-law lives with my wife and I. She has Alzheimer's. My mother, of course, was here with us for 3 years. Both my wife and I both developed high blood pressure. And now I got some stomach issues. I think stress has a weird effect on your body.
I think that is a very stressful situation.
Yeah, you know what though? So many people are going through it. When you're a caregiver, it's interesting when you're a caregiver, you don't have to explain things to another caregiver. We all get it. So it's sometimes some things are funny. Like my mother-in-law thinks that the people in the TV are in the room with her. So my wife says, no, Ma, Betty Davis is dead. She's not in the room with you. She's watching a movie, an old time movie. Folks, it's 7:47. Do your best. I'm sure you'll do all right. Be prepared, have those things. Breathe, please don't spend an inordinate amount of time on one problem. Don't spend 20 minutes on one problem. You got 35 to do. Take your best guess and move on. Make sense?
Yep.
Yes.
Yes.
Yeah.
All right, you guys have all been whatever, and just breathe. It isn't all that. My experience has taught me people who take summer courses are great students because you know the workload. You know, you've taken them in the past, you know the workload. And the good thing is you get it done in 5 weeks. The bad thing is you get it done in 5 weeks. All right. And the reason I'm not showing myself is somehow I was out in the rain today. My hair look like I've been on a binge. Let me see how it looks. Yeah, there I am. Not that bad. Not that bad. Kind of phone on you. All righty. Listen, if you have a question between now and 11 o'clock tomorrow morning, or if you're starting like Ann is starting at 5, 6 o'clock, feel free to shoot me a question. I'll answer it for you.
All right. Thanks, Professor Gomes.
Thank you.
All righty. Enjoy
Thank
your
you.
night. Good. I'm glad you guys logged on. Thank you. Listen,
Thank you.
it won't go, put it this way. I'll know who logged on today because I'll get the attendance. And what I'm looking for, if your average is 89, I looked at you logged on, guess what? You're getting the A minus, okay? Because you took the
Oh.
time. All right,
Thank you.
Thank
All right.
you.
Quite welcome. Good night.
Thank you.
night.
Good night.